Okay, today we're looking at the correct procedure for installing a cylinder head. And this is one of many video segments that we've looked at on rebuilding this DT, which is a diesel turbocharged 408 International engine. So in particular, we've taken a look at installing the liners and correcting and making sure that the liner protrusion is correct. The liner protrusion is in place so that when we clamp the head on and it squeezes the gasket down into place, then we have a certain amount of the liner sticking up that provides a clamping force that holds the liner in its respective position in the counter bore and into the lower parent bore where the seals are. So if we take a look, first of all, we're going to install a couple dowel pins, which are part of the OEM assembly for installing the head gasket. They're tapered on the top, they're a split ring configuration, and I'm just going to put them down into the block and bottom them out. There's two for locating the position of the head gasket, and we just tap them both in till they're bottom. If there is any burrs on these, at this particular point, it's going to make it hard to actually mate the head down into position. So we want to do an inspection on this, make sure there's no burrs and don't overdrive them, otherwise they will be burred and it makes it harder to actually mate the head into position when the gasket is there. So the next thing we're going to do is install the head gasket. The deck of the block has been cleaned, the liner protrusion is all correct, and now we're going to install a new OEM head gasket. A couple things looking at the OEM head gasket: it's a Teflon coated gasket which allows for a lot of sliding. And as part of the gasket makeup, there's embeddability, conformability, creep relaxation. And one of the things about the gasket structure, creep relaxation, is the ability for the gasket to expand and contract and still maintain integrity to promote the sealing and prevent any leaks of oil, coolant, and compression. Compression is also sealed through what's called the fire ring. And on this particular cinched style gasket, which means it's a bunch of web material that's interlocked like this, and when we compress it and tighten it together, it becomes uniform and one. That also allows for some movement of the gasket so that it can expand and contract without failing. Most of the time, head gaskets will last at least the life of the engine. If not, if there's a failure for whatever reason, overheating, lack of coolant, or failure for the oil or compression or coolant, then we could actually have a failure that could cause some serious bottom end problems. So going ahead now and installing the head gasket, we want to make sure that we are putting it in the correct position. Some manufacturers, and I don't see it on this one in particular, may actually indicate a top location to promote the correct sealing and the correct orientation of it. This one here, we have our lifter gallery holes and oil return passage holes on the cam side, and the gasket goes in just like this. The question always comes up: can we put glue, adhesives, or gasket eliminator on head gasket surfaces? The correct answer is no. You always put them down dry, because then we compromise the integrity of the gasket. The gasket already has a Teflon coating on it, and that allows a lot of that sliding resistance to be met as the engine head and the block expands at different rates. Depending on the gasket that's being used would be dependent upon the types of components being used. If we had a cast block and an aluminum head, there's obviously going to be a difference in the expansion and contraction ratios based on ambient temperature and operating temperature of the engine. So the head and the block will expand at different rates, so the gasket is supposed to be able to take that abuse to promote the correct sealing. You can see right here on the deck surface now, the gasket's in place, and the gasket sits right into the area around the liner, and the fire ring of the gasket sits down right on top of it. Now it still is higher than the liner. So when we install the head and torque the head down, it crushes the fire ring of the gasket, compresses the gasket. So the gasket, another part of the characteristics of the composition of the gasket is compressibility. So we actually have an available amount of area in the gasket that we can compress it down. That's based on a manufacturer's design, how far it's going to come down based on the torque, the number of fasteners, and the type of material that it's mating against. So now that we've got this in, it's clean and dry, we can lower the cylinder head into its respective position. One thing that a lot of technicians overlook when they're installing this is cleaning out some of the deck holes or the bolt holes in the deck. We also want to make sure if for any reason we need to run a tap down there to remove any debris, any of the adhesive that may have been installed in there from the factory to promote sealing of the threads on inside the block. So we've got that in position, and then we're going to lower the cylinder head down into position and then start to assemble the top end. Okay, so now we've got the head ready to be positioned, and normally we would have a second technician to do this, but in this particular case I'm just going to go ahead and I'm going to lower the head down close to the pins and then position the head so that it drops onto our alignment dowels. And there's one end, and I'll drop the head slightly again and then come to the front side and we're down in position. Okay, so I can move the head a little bit and I know that I'm mated now, and we'll bring the lifting bar out of the way, and this spreader bar can be adjusted so that when we lift the head off of the engine we're picking it up equally. Sometimes technicians will pick it up with a strap and they'll actually cause a warp or distortion in the head, especially if the head's been removed when there's still some heat from operation. So we'll get this apparatus out of the way and then we'll continue with the installation. So next thing we got to do is, now we have the head positioned, is we want to install all of the push rods. And the push rods have been cleaned and checked for straightness, and the ends, the contact pads, are all in good shape. So now we're just going to go ahead and install them. They sit down into the lifter on this particular engine. And then we're going to install the rocker arm assembly. So I've gone ahead and lubricated the fasteners and set it all up so I can drop this assembly all together as one. Line up the holes, drop them down into position, and then I need to come back to the other side and position the rockers into the push rods so that the assembly can be tightened and torqued into position. So I'm just going to go ahead and make sure they're all lined up, and then I'm going to start the fasteners down into position. Now I'm going to talk about when you install the head bolts correctly, we need to put oil in certain areas. This ones have already been oiled, so I've gone ahead and done this so that we can take a look at the correct positioning of this when it's installed. We want to make sure that all of these are positioned in the right spot. Then we can go ahead and just run the rest of it down by hand and snug it up so that we can go ahead and install the rest of the fasteners. Now this manufacturer of this particular engine wants us to leave these bolts here to be torqued, the last two and the pedestal to be torqued at the end. And we're going to go ahead and we're going to take a look at the correct adjustment procedure for setting the end float position on this rocker shaft. And that will be once we get the rest of the fasteners in and do a rundown torque. So okay, as per the procedures for reassembling or installing the cylinder head and the valves out of the service manual, you can see that we've gone through the procedures for installing the push rods, the rocker arm assembly, dropping the head into position, and again doing a rundown torque. This one's showing a D-torque using an impact gun. You must be very careful if you're going to D-torque a head with an impact gun. If you are going to pick that method of removal, well, I would recommend one of the first things that you do is go in here and crack these bolts loose with a Johnson bar, so then you break the torque and then you can run them out. If you run them out with an impact gun, you could run the risk of not having the hand feel of detorquing. And if there is a bind in the threads or a rusted thread or a slightly damaged thread and we just zip it apart with an impact gun and start piling all the fasteners, then we don't know the hole it came out of, and we could have potentially caused a pulled thread in the block, which now would be required to be repaired with a Healy coil, or maybe even drilled and tapped oversize, and then a key insert or some thread replacement repair to be put into place. So we're going to go ahead now and take a look at the correct method for lubricating the head bolt prior to installing them. Okay, so we take a look at the head bolts, and some of these head bolts are kind of in rough shape. We've gone ahead and cleaned these. There is a bit of rust pitting and so on and so forth, but because this is a lab engine, this is a good engine for students to see the damage that could potentially cause a failure when it's put back into service. My recommendation would be, on this particular engine, to put back into service into the chassis for daily usage would be to replace these fasteners, because they have been, in some cases, slightly compromised with some of the pitting. Fasteners are also checked for the overall length from the underside of the head of the bolt to the end of the bolt to find out, is the bolt stretched too far. If it's stretched too far, then we won't be able to put the clamping force or the torque value on it to actually bring it down and hold the components into place. And this is typical for all applications. So we've got these bolts all cleaned. Next thing I like to do with them, and you can use an oil can, you can use your hands, you can have a bucket you want to put them in, and I'm just going to lubricate all these. And what I'm trying to do is get enough oil under the underside of the head of them and onto the washers. And I'm not using very much oil, but enough. And then onto the threads. Okay? And when I do this, the next process is when we take a look at it, we pick this up, we can rub it with our hands, then we've got lots of oil on the fastener. We can turn it, we can get lots of lube into the threads, onto the shaft of the bolt, the shank of the bolt, and then to this side of the washer, and the underside of the head, so that when we install it, there's no resistance to torquing between the head and the washer, no resistance to torquing between the washer and the pedestal that it sits onto on the cylinder head. So now that we've got them all lubed up, we just go through them, lubricate them all, make sure they all have a nice coating of oil on them. And most manufacturers recommend that engine hardware, and most hardware in the chassis in general, is always lubricated with light oil to eliminate some of the friction from initial torquing. We don't want to be fighting against rusty fasteners or rusty or maybe pitted or slightly used fasteners that could actually limit or restrict the torque we're trying to attain. So we continue on with these until they're all lubed up. On the shaft also prevents any more pitting from occurring. Now, the precaution that we have to take a look at, I've got a lot of oil flooding these. I wanted to make sure I have enough everywhere so that I get a good torque when I install them. So the next process is one, we've already cleaned these, inspected them, now they're lubricated, and we want to just wipe off the oil. So we want to have just a residual amount of oil. I don't mind having extra oil up here, because this is where we're torquing. Okay? We want to wipe off some so it's got a light coating on it, and just wipe the threads so we don't have too much on the threads. The problem is if we take one flooded with oil, like this, and then we put it into the engine, we could end up allowing the oil to run down past the threads and fill the relief cavity below the tapped area in the block. If we do that and we torque it down, what can end up happening is we get hydraulic pressure built from the volume of oil, and it can fracture the block or change the torque rating, which affects how that engine stays together. So if we continue on, we're looking at the service manual now for one, the torque specifications, and it tells us that we have a three-stage pattern. So one, the very first one gets torqued to 110 foot-pounds, 155, and then the final torque at 165. There is also a sequence here for stage 1 and stage 2, which is a circular pattern that moves from the center all the way out. And then the final third stage, where we do the final torque to 165, it's a linear pattern, front to back. Okay, so I'm going to go ahead now with my impact gun, run down to the lowest setting, which is going to be somewhere in the range of about 75, maybe 80 foot-pounds. I'm going to follow the sequence A, and then I'm going to do the torquing pattern over again with the appropriate torque. Okay, so going ahead now with my impact gun turned down. It's a long process to do this by hand if we're going to continue with it. But I'm going to start in the center. I'm going to work through my pattern in a circular pattern until we go all the way out. Now we've gone ahead and run these, whoops, last one. Gone ahead and run these all down. We want to make sure that all these push rods are in the right position also. So we're good to go there. And we're going to continue on. So I'll go through the second sequence and then I can pull it up to the first torque, which is 110. And I'm going to again go through this as a circular pattern. Last two. So now taking our click stop torque wrench, I've set it to 110. I've done a rundown with the impact gun, and now we want to go ahead and do the torquing. When torquing is done, we always want to try and be outside of the engine here. So if we're torquing in here and we're pulling across the top, we run the risk and potential of hurting our fingers or damaging tools. So I always want to come outside of the engine in a safe position. Now the other thing I can do too is I can also put my right leg back so that in the event, if this flips and comes off, I don't go backwards. I've got some way of controlling the effort of me going backwards. So I'm just going to pull this up to the torque of 110 and then continue through the pattern. And then, okay, so we've gone ahead and we've done the initial pattern torque to 110, and then we went and we did our second stage to 155. Prior to doing the final torque, the manufacturer recommends that we need to set the end float on the end rockers. So we want to make sure there's enough side clearance in this so that when the engine's running that this does not bind against the pedestal. I've gone ahead and torqued these. I'm going to take the torque back off of it. So we've gone ahead and we've loosened the pedestal off now. Okay, so we can actually put our feeler gauge inside between the pedestal and the rocker arm. We have to have a certain amount of end float here. End float is controlled on other ones by the spring assembly. So it can position itself as it needs to maintain correct geometry. These will move slightly as the motion of the push rod pushes the rocker arm. So we have this spring in here to take up some of that play. There's nothing on the end, so the manufacturer prescribes a value that we have to have there for a running clearance. So all we're going to do is put our 5 thou shim in place, and then we're going to push the rocker shaft over to it, and then simply tighten down the hardware. I'm going to check to make sure we have that 5 thou running clearance, and we got too much, so we'll go back to the drawing board again and get it to where we have the 5 thou minimum clearance. So our 5 thou shim goes in there now. We have the right amount of clearance, and you can see it's not excessive. Then we can just snug this back up, and then we move to the other end of the engine. So we'll come down to this end, and again, put our 5 thou shim in here, adjust the pedestal over so that we eliminate the clearance, and have the 5 thou shim to fit in so that we have sufficient running clearance. And you can see it takes a little bit of time. It's a bit of a finicky process. And there's our 5 thou. It's snug. I'm just going to bring this up so that it's in position. Check that my 5 thou drops back in there. Check the clearance on it. I've got some play there. And in this particular case, I'm going to continue on and I'm going to tap it over under torque because I have to get it to be just a little bit tighter. So I'm going to snug the bolt up a little more. Then I'm going to put my feeler shim back in and snug it up. So now I have a nice drag on that, and it drops back in, which indicates that I have that 5 thou of end float or shaft running clearance. So now to make sure that that is in position, we're going to pull it back down and then go back again. It's always good to recheck your measurement after you have set it, in case you tighten it and then the measurement changes. So again, I have the 5 thou, I check it, I can feel it, and I'm good to go back now and re-torque these fasteners based on our sequence 1 and sequence 2 step. So I can go back now and in the correct position. That one's torqued. And then down to the other one. And second click on both to make sure that my torque is attained. And now the entire top end is torqued based on sequence 1 and sequence 2. So now we're going to go back one more time and follow through the pattern again at the final torque stage, which is 165. Now they're starting in a linear pattern and we're walking from one end of the engine to the other. We're starting on the second fastener. I'm going to get into position where I'm running safely, and I can go ahead and pull to my 165 final torque. Now what that does for us as a final torque, it provides the clamping force needed to hold the liner in position so the piston can move up and down in it effectively. It promotes sealing between the fire ring and the top of the liner flange, and it also promotes sealing of any coolant or oil in the fire deck to the block deck surface. So we continue through this entire pattern until we have torqued the entire top end. So, moving back down to the opposite, I was just double checking my position. And I will run through this pattern one more time, and I will do what most people do when they torque, is they do a double click. When you double click, you don't want to go any further. A lot of people pull it to the click and then pull through the click. You only want to pull up to it and no further. So, and again, I will double check that once I am done the entire third stage of torquing, which is the linear pattern, and it is our final torque. Again, we torque that one when we set it, 110, and then up to the final at 165. Okay, so now it's torqued. So the next thing that will be done is we're going to bar the engine over. We're going to recheck all the motion and operation of the rocker arms on the top of the engine. Make sure that we can still have our running clearance on the spring-loaded portions. And then we'll go ahead, position the engine, and do the valve set. And that will be in one of the next training videos.